Welcome everybody, contestants, guests, team leaders to IOI 2023. I hope you've found your hotels, your bags, your official IOI sunglasses. I look forward to seeing you all at the practice competition tomorrow. So I'm super excited for IOI this year. Some of the teams, this will be the first time we see you since COVID in person. It'll be a full IOI on site. We're going to have excellent problems. It's a wonderful city. I look forward to it.
Welcome everybody to IOI 2023 here in Szeged, Hungary. It's great to be here. I am really excited to be here, especially because tomorrow evening, Tuesday evening, we get to see the tasks for the first competition day. And the buzz and the butterflies in my stomach are really there because I love that moment of getting the tasks for the first time.
Hello IOI and welcome to Szeged. Szeged is called Sun City in Hungarian and it lived up to its name with the 39 degrees. I know that this day was tiring with all the traveling and checking in and everyone is having dinner right now, but tomorrow is the big day because we are going to have the opening ceremony for the IOI 2023, which is for a long time the first one to be held fully in person. Welcome.
It's still translation night for IOI 2023. This is the first translation night. We're at the front of the room, and behind me, you see the scientific committee discussing the comments that people have sent in about the tasks. Now, obviously, we can't go too close because at this point, everything is still in quarantine, but it's nice to see how many people are actively working on all of these tasks. Let's just slowly walk to the back of the room and see what we can find out when we talk to the people.
We have spent months as a scientific team thinking through the task statements, preparing them, refining them, and then this evening people see things that we had not thought of because maybe they interpret words differently, they structure the grammar differently, and so something has a slightly different interpretation that you want to avoid. So there's always things for these people to fix.
Hello everybody, welcome to IOI 2023. We're broadcasting to you live from the PIC Arena here in Szeged in Hungary. We've been having a wonderful time, it's really, really cool. There's some issues from time to time, which is why we're running tiny little bit late, but everything is going fine. As promised, we will be talking about the tasks first. That's what we're starting off with now. So let's get started with my big friend Mate. We're going to talk about the task longest path.
Longest trip, but yes.
Longest trip. And the longest trip is a task about the excursion tomorrow.
Yes.
Because tomorrow everyone's going to go on an excursion, and unfortunately we've lost the map.
Yes, in the story at least.
And we know which landmarks we want to go visit.
Yes, we know that there are end landmarks at Oldottak, and we asked the contestants to help them find the best way to move around.
And we want the longest trip. We want to see as many landmarks as is possible.
Yes, we want to visit as many as we can, and they should output a longest path.
But we don't know the map. We don't know.
We
how
don't
the
know
landmarks
where are the
connected.
roads are. Yes.
Are all the roads of the same size, same length?
Yes, the lengths are all one. It doesn't matter.
It's connected or not.
We just want to visit as many landmarks as we can. Yes.
Okay. And what we're trying to do is find the layout of the map that we don't know by asking questions to someone else about the map.
Yes, we can ask the dispatcher at Oldottak questions. Here we can see how we can do that. So we can give the dispatcher two different sets of landmarks, and they will return if there are any roads between some node in A and some node in B. So they return yes if there is a road between, and they return no if there isn't any.
So yes means you can find one landmark in A and one landmark in B that are connected.
Yes.
At least one landmark.
At least one. We don't tell which two.
And it's interactive.
Yes, it's interactive.
And so this feels like a very hard task. But when I was looking at the scoreboard earlier today, some kids already had 5 points after 10 minutes. Yeah. Tell me.
Yes, in my opinion, this is the easiest task. In the first task, there is a special condition that helps the contestants reach the 5 point. So basically, we know that this landmark system connections have a density property, and this density means that if the density is D, that means that between any three nodes, landmarks, there is at least D edges, roads. So for any three,
and it just tells you how many roads there are between them.
Yes.
And so D could be 0, 1, 2, or 3.
In this problem, D is at least 1.
Okay.
That's the hardest part.
Okay.
In subtask 3 and 4. In subtask 2, D equals 2. That's much easier. And in the first subtask, D equals 3, which is the easiest one.
But D equals 3, that means for any 3 points, there are 3 roads.
Yes.
And no points are double connected.
Yes, only simple connections.
So if that's for any 3 points, that basically means that every point is connected with every other point.
Yes, it's a click.
So, well, I can see how you find that the easy task, because that basically means if everything is connected, the longest trip is going to be visiting everything.
Yes, just output the landmarks in any order if you want.
Okay, so you can just output anything, and that's what these kids did. They looked at the task, they read it, and they understood that the trivial situation was just output a permutation.
Yes.
And by
any permutation.
And are there any kids that actually outputted weird permutations, or do they all just output the number 0 through n-1?
I checked some of them. All of them printed 0 to n-1, so that's the most easiest.
Nobody was creative.
Nobody.
Okay. So let's make the task a little bit harder. So if you're still with us at home, we're looking at the task longest trip from IOI 2023. We've just explained what the problem is about. There you have a graph with landmarks that you want to visit, but you don't know the exact layout of the graph. You know some properties about the graph, and there are questions you can ask.
Yes.
Let's go back to these questions that you can ask.
Okay. So in these questions, you can give the dispatcher two pairwise distinct set of landmarks. So this is like some nodes A, some nodes B, and the dispatcher will tell you yes if there is a road between these two sets, and they will tell no if there isn't any. And in the harder subtasks, there is a limitation about how many questions you can ask to the dispatcher.
Right, because if you don't have any limitations, you can just ask for every pair, is
Yes.
there a road, and then very quickly you will build up your whole map, but it takes you n squared questions, basically.
Yes, that's a low point solution.
Okay, but that would still score some points.
Yes, it can score, yeah.
Okay, well then how do you ask more clever questions?
Yes. So basically, almost every time it's better to just ask if there is one node connected to another node, because it's easier to just focus on two nodes instead of two big sets of nodes. And for the second subtask, the idea is to iterate through the nodes and try to build the longest path. And when you try to work with your new node in the iteration, you can check if it's connected to the left end of this longest path. If it's connected, it's cool, you have a longer path. And if it's not connected, based on this property,
you know it's connected to the other side.
The other side, yes. So with one question, you can always make the longest path bigger with one.
And because of d equals 2, you know, is it always connected, the graph?
Yes, it's always connected.
So it always has to be connected. So you just start with one point and you say, this is a start, this is on my longest path.
Yes.
And I look at another, in my triangle, I look at another.
Yes, you can start here. Yes, start here. Okay, this one is connected. Yes, that's cool. Okay, go here, connected. Oh, yes, cool. Okay, here, it is connected to here. Oh no, but based on this property, it will be connected to here. And we can just go
But
through.
if this is not connected, you could also just connect this to anything else.
Yes, that's also true.
Right? So,
Yeah.
so that's a different way of looking at it.
Yeah, there are more
There are
ways to
multiple
approach
ways
this.
of
Yes.
looking, but it's the same idea.
Yes.
Right? If you don't have a connection, then the point is connected to anything else in the
yes.
set. Because you know d equals 2.
Yes.
So that's pretty clever if you think about it. So you just ask a question, if 2 points are not connected, you know that both of these points are basically connected to everything else in the group, but you don't know anything else there. But so this is the way you work to just slowly start building your graph.
Yes.
And how many of the kids that you've seen saw this quickly?
It's a little bit harder than the first subtask. So for the first subtask, the contestants only needed like a few minutes to solve. This is a little bit harder because now you have to ask questions. In the first subtask, you don't need questions, just print any permutation.
Right.
Yeah.
But here you're building your answer. So yes, you know the graph as well, but we don't care about the graph.
Yes.
Because we care about the longest
The
strip.
longest strip, yes.
Okay. So I think it's time to go to the hardest subtask. D equals 1.
Yes.
Tell us more.
In D equals 1, so in subtask 2, we only built one path, but in subtask 3 and 4, we should build in one of our solutions 2 paths simultaneously. And the similar way, just iterate through the landmarks, and when you meet a new landmark, just ask if it's connected to the left, your left path. If it's connected, that's super cool. You have a longer path here. Yeah. If it's not connected, you can ask if it's connected to the other path. If yes, okay, you know again have a longest path. If it's not connected, based on this property,
You connect the two paths.
Yes. And from now on, you have a very long path, and you have another path consisting only one node.
And you could just continuing at this one, right? Yeah, that's the one node that you continue with.
Yes. No, so after this, you have this long line and the other short line consisting only one node.
Right.
And just go through the next node
Right.
and check where is it connected. Yeah. So basically, for subtask 3, this is enough because you in subtask 3 you are not forced to output the longest path. Half of its length is enough. So this way we build two paths, and outputting the bigger one is enough
Okay.
for subtask 3. But in subtask 4, you have to try to connect these somehow in the end. And you can check if these two ends are connected, or these two ends, or these two ends, or these two ends. If any one of those are connected, you are good. You have the longest path. If not, you know that this and these edges are nodes are connected. So basically, you will have two circles.
Two cycles.
Yes.
Yes.
Yes. And after that, you should look for another edge, if there is any. Because if there is another edge between these two cycles, you can find the longest path somehow like this
Right.
way around. Yeah.
But that, so it feels to me like the core thing was subtask 3, figuring out to build two paths at the same time.
Yes.
And then 4 is like the cherry on top, where you think it even a little bit more. Can we do even better?
Yes.
So the cycle is important, and figuring out how to connect the ends.
Yeah, there are more solutions, but most of them use this two paths idea.
And it's nice to observe that if the ends are not connected, that you actually have to have that cycle, and then it no longer matters where you connect in the middle because it's a cycle. Okay, so I hope you at home are enjoying this. So this is the explanation of the easiest task.
In my opinion.
In your opinion, the easiest problem. What we're going to do is we're going to go back and show you a little footage of the contest hall, and then we'll come back with the explanation for the second task. So if my people back there will switch us back to the contest hall, that should be great.
contestants, guests, team leaders to IOI 2023. I hope you found your hotels, your bags, your official IOI sunglasses. I look forward to seeing you all at the practice competition tomorrow. So I'm super excited for IOI this year. Some of the teams, this will be the first time we see you since COVID in person. It'll be a full IOI on site. We're going to have excellent problems. It's a wonderful city. I look forward to it.
Welcome everybody to IOI 2023 here in Szeged, Hungary. It's great to be here. I am really excited to be here, especially because tomorrow evening, Tuesday evening, we get to see the tasks for the first competition day. And the buzz and the butterflies in my stomach are really there because I love that moment of getting the tasks for the first time.
Hello IOI and welcome to Szeged. Szeged is called Sun City in Hungarian and it lived up to its name with this 39 degrees. I know that this day was tiring with all the traveling and checking in and everyone is having dinner right now, but tomorrow is the big day because we are going to have the opening ceremony for the IOI 2023, which is for a long time the first one to be held fully in person. Welcome.
welcome back to the IOI 2023 live stream here live in Szeged, Hungary. We're outside, the temperature has dropped a little bit, which is good, because it was so hot when we arrived here, 39 degrees in the shade. Today is a lot better, but as you can tell, I'm still sweating, but that's because the excitement of the tasks. With me, I have my friend Aaron. Do I pronounce that correctly?
Yeah, it's good.
And Aaron is one of the really smart people on the host scientific committee, and he will help us understand problem number 2. And this is the problem called soccer.
Yes.
Why did you not call it football?
Well, the proposal by the 2 Japanese authors used soccer, so we stayed with it.
But did you actually discuss this?
Well, I actually thought about it, and it wasn't a big issue, I think.
Oh, look, I don't think it's an issue, but you were not there for the translation session last night.
Yeah,
but
yeah.
If you've been watching the translation interviews, there were people complaining about this, which was really, really funny.
Yeah, they said it's football.
Yes.
So at least there's some controversy.
And,
I like it.
And at least we know that people read the problem statement.
Yeah.
So the soccer problem is a problem on a rectangular grid.
A square, yeah.
Of n by n, a square grid of n by n.
Yes.
And every square is either empty or has a tree in it.
Yes,
And
exactly.
I am very good at drawing trees, as you can tell. So tell me a little bit, what are we trying to find in this grid?
Well, we are trying, this is a forest, first of all. We are trying to build a stadium in the forest, and a stadium is such a subset of cells that it is possible to kick a ball 2 times from any 2 cells of this stadium. Kick is
So if the ball is here,
so like a ball is here.
how can I kick it?
You
Can I kick it here?
Yes,
But I can't go through the tree.
you can go to the tree.
Can I kick it here?
No,
That's
only
not okay.
horizontally or vertically, but any number of cells.
So I can go as far as I want to,
Yes.
or as short as I want to.
Yes.
And so in one kick, I can get this ball here.
Yes.
And what is the question?
We have 2 kicks,
Okay.
and we want to find the subset such that these 2 kicks are enough to move from any cell of this subset to any other cell of this subset.
So this would be one of those subsets.
Yeah.
Because I can kick the ball from here to here, and kick one and then to here.
Yeah.
So is this a solution you're looking for?
No, because we want to find the largest such subset.
You want the largest subset where you can always kick the ball and keep it inside the stadium, basically.
Yeah.
But, so if I look at this, 2 kicks means I can go around 1 corner, basically, but I can't kick it from here to here.
Yeah, you can't go around the trees. Basically, it's observation.
So, right, so that's just one of those key observations that the students are supposed to make.
Yeah.
And we don't give them this observation, this
No.
is something the students should
Yeah,
find
they
out.
should tinker around and see this for themselves.
Fiddle with it and figure out, okay, I can't go around the tree.
Yeah.
But, so I don't know what the solution is here, but it seems like something like this might work.
Yeah, also adding these too.
And I can add this too as well, so I can make a pretty big stadium
Yeah.
here, where I don't have this bit in and I don't have this last one.
Yes.
Because that would be blocking the ball at some point.
Yeah, the ball couldn't go with 2 kicks around there.
So, an n by n square, how large can n get?
Well, there are several subtasks to evaluate the solutions with different time complexities. N can be as large as 2000, but there are also subtasks with n where n is at most 3, n is at most 7, n is at most 30, and then is at most 500.
So if n is at most 3, and we've drawn these, we prepare these things for the viewers at home. So for n equals 1, we've drawn the grid here.
Yes.
And so there can be a tree or no tree.
There can be a tree because there's also the thing that there's at least 1 empty cell in this grid, so it's gonna be empty.
So for this one, you know that this is the largest subset.
Yeah.
Now we look at this one. So how do we know anything about how many trees can be there?
Well, there can be 1, 2, 3, or 0.
Right, because 4 trees would fill it up.
Yes.
So if there's 1 tree, then
Yes.
basically we always have the rest.
Yes.
And for 3 trees, that seems very simple because there's only 1 empty spot left.
Yes.
And then for 2 trees, if I look at this, we have 2 options. They're either next to each other,
Yes, or diagonally.
or the trees are here. So if the trees are here, my maximum subset is still 1.
Yes.
And if the trees are next to each other, my maximum subset would be this.
Yes, this do.
What are you supposed to output to the judge?
Just the size.
Oh, so you just output 2 in this case.
Yes.
You don't have to.
You don't have to construct any the subset, so don't have to print like an n-by-n matrix. You just have to print the number
Okay.
cells.
Now let's go to n equals 3. This seems to get a little bit harder.
Yes, it's a bit complicated. I don't think that it's possible to solve by hand. So the intended solution is just taking every subset, like there is 2 to the 9th subsets, like 512. And
Why
just
are there 2 to the 9th?
because
Just for the viewers at home?
because there are n to n squared.
There are 9 squares.
And 9 squared, and we can check we can decide if each of the cells is in the subset. Well, and then
No, we're talking about the trees now, right? Every square could have a tree or no tree.
yeah, well, no, we have some trees, and we need to check all the empty cells.
Okay.
So for each empty cell, we need to decide if we are examining a subset that it's if it is in the subset or not.
Okay.
And so in the worst case, there are 9 empty cells. And so it's 2 to the 9th, and then we can just check by brute forcing every 2 cells that if they are connected, check that.
And
By
how
2
long
kicks.
will the brute force solution take?
Sorry?
How long does the brute force solution run at this size?
Very small, like 0.1 second. Like
How long
not very
does it
small.
run for n equals 7?
Many seconds.
Oh, seriously? And for n equals 2000? Will we still be alive by the time there's a solution?
I don't think the universe will be alive.
You think the universe? So we're talking about the different algorithms you can come up with. And so if you have the brute force algorithm that will work for n equals 3, you say it already won't work for 7. Will it still work for 4? Or not?
I doubt it. Maybe if we do some dark magic, like it
Right.
might work.
But so brute forcing is not the best idea, but if you're trying to score some points and you don't see any more clever solutions, I mean, this is a competition, right?
Yes,
It's
you
not-
want to get as many points as you can.
And at your skill level.
Yeah.
So if this is your skill level, that's why we have a task like this in there. Okay, did you see any students submit a brute force solution?
Yeah, I see. I saw.
And because you're in the scientific committee, you get to see all the source
Yeah, I
code.
checked all of them, and I was nervous whether the tests are strong, so I needed to check all the solutions.
You've looked at every solution that came in?
No, those that have very low points, I didn't check, but just those that have had a bit bigger, because.
And
those
so
have
far,
bigger
you're
impact.
thinking that your test set is great.
I feel like it.
But that's good, right? That's good.
Because I prepared the test, so that's why I was nervous.
No, but that's good. So we're at n equals 3. Okay, so brute force. Let's go bigger. You said the next size was n equals 7?
Yeah.
What are we doing special for n equals 7?
Well, actually, apart from these size limitations, there also you can also get points if you can judge whether you can judge if all of the empty grids are a stadium. So you can get 25% of the points for deciding this for a subtask.
So you're saying that if these are x's, then the whole
the whole board is
Everything is now
stadium.
a stadium?
And if you can decide this, then you would get 25% of the points for that subtask that is contained.
And this is just a matter of looking at all the trees and seeing if there's something empty, if there's a tree or a set of trees where they have an empty cell on both sides, or is there a more clever way of doing this?
It's a bit more complicated. There are 3 things that we need to check. First of all of the rows have to contain the empty cells as a connected interval.
Non-stop?
Yes.
Okay.
The second thing is that all of the intervals have to be, so for two of these intervals, either one of them has to contain the other, or the other has to contain the one.
I don't understand.
So we have an interval A and B, 2 rows. Either A has to like contain B, or B has to contain A.
Get smaller.
Yes. So either this has to be the case, or this is A and B, or A has to be smaller and B has to be larger. So that there shouldn't be intervals like this, because then we would have to kick the ball 3 times.
Because you do one kick to get into the other interval, and then one kick to get there.
Yes.
Right.
And also, if we look at the length of these intervals, it has to be unimodal. So first, at the top, it has to be small, then increase up to some point where we have the longest such interval, and then have to decrease from then on.
And is that enough? Is that if you have that, and
Yeah.
you have that for both, you check it for the rows and the columns, or do you only need to check it for
Just the rows, and if these 3 things are correct for the given test case, then it can be proven that indeed the whole board is a stadium.
But so you said 3, and I'm at 2. Oh, so the first one is
that
the
intervals.
first one is that they're consecutive.
Yeah, they're the empty cells.
The second thing is that they have to be inside each other.
Yes.
And the third one is
Third one is that unimodality. So
this. Right. Okay, the diamond.
Yes, it's said to be a diamond. And technically, there was a solution which said. It created a function which said check diamond.
Oh, seriously?
Yes.
So you saw that in the source code of the
Yes.
And does that make you happy, that seeing that they've actually figured out what you want them to figure out?
Yes, it's a good feeling.
Okay, good. But then, but this gives you 25% of the points.
Yes, it gives you 25 points if you can implement these checks relatively efficiently, so like in n squared time.
Okay.
And then from there, also these observations give us a solution in time complexity of n to the 6th, DP solution.
N to the 6th, that's still pretty big.
Yeah, but it works for the 30 subtasks, up to the 30 subtasks.
So for the viewers at home, like we said, we're looking at efficient solutions, but we also give points for not so efficient solutions.
Yeah.
And so brute force is horrible. This is the order n to the 6th.
Yes.
And yeah, that gets big.
So we actually wanted to provide points for a lot of points for the n less than or equal to 7 subtasks. So to give points to any correct solution that might run in a bit better than the very brute force solution.
Okay.
So yeah, this was our consideration.
But we're now at n equals, we're not yet at n equals 2000, right?
Yeah,
with
we are just 30, yeah.
We're just starting.
Yeah.
Okay,
Yeah.
so what's the next observation we can make?
Well, next observation is that if you take a stadium, like so, maybe like here, one more, like here, and
We're making it slightly easier.
Yes.
Okay.
I can say that.
Mm-hmm.
Maybe add here like this. Here.
Okay.
So an observation we can make about stadiums is that they can be made up as the union of rectangles. So for example, this is a stadium, as you can see it, because that the three requirements are met.
Right.
So we can take like this rectangle. We can take like this rectangle, and this rectangle, and this rectangle.
Okay.
And the stadium is made up from the union of these rectangles.
Right.
And to solve the n less than 500 subtasks, we have to make a clever use of these rectangles and have to know a few things about these rectangles. So
you're trying to find the rectangles first and then try to use that to build the biggest stadium.
yeah.
Because there's a lot of rectangles in it.
Yeah, there are a lot of rectangles, but one thing to notice is that we're not interested in every rectangle. For example, if you take a look at this rectangle, it doesn't seem like it's useful.
Because it's completely contained.
Well, because
You can expand it.
Yes, you can expand it. Exactly. So we are looking at non-expandable rectangles.
Okay.
And the fact is that there are at most n squared such rectangles.
Okay.
And we can go into the proof of that, or just...
No, we don't have to go into the proof of that right
Okay,
now.
yeah, well, for those interested, it's like you can prove it with like histograms and stacks. It's a bit classic, or like it can be.
But let's stick with this. So we find the non-extendable rectangles.
Yeah.
Okay.
And then what we do is we do DP on them.
Okay.
So we take a non-expandable rectangle, like this one. There are like, here are trees, here are, and there are trees on like the upper half.
Right. Because otherwise it would be extendable.
Yes.
Yes.
And then what we can see is if we go through the upper half of this rectangle, there's like these intervals. What we can do is if we take these intervals between the trees on the top half,
Okay. Yeah.
and we like search for these intervals, how far up can we go until we meet with another tree, and we check how far down we can go until we meet a tree. And then the DP is basically just take this rectangle, this big rectangle, and look at the smaller rectangles, and then calculate the answer for the smaller rectangle. You will have some common piece. You can like take out that, like it's a set thing, like a plus b minus the intersection.
And you can only you can only take one of those four.
Yeah.
Because if you take more than two, you have,
Like,
by
yes.
definition, two cells with a tree between them, and we've already seen that that's not possible.
Yeah.
Okay.
And we can check all of these intervals, and then take the maximum with such that with this big rectangle, the intersection.
How can we grow it?
What?
How can we grow? Which one is the best to make it the biggest?
Well, so basically it's a DP solution. So it's recursion. So for this smaller, we also check these, and then when we go back in the recursion, we see that for this rectangle or like stadium, we have some answer, but we also have this rectangle which has this common piece with the stadium, which we solve recursively. So we just add these two areas and take out the common.
Right.
Yes.
Take the overlap.
Overlap. Yeah.
But you said that that works up to n equals 500.
Yes.
Approximately, I presume.
Yeah. Because for that we use brute force to find like the maximum length that we can go up and down, and to also solve the last subtask where n can be up to 2000, we need to use data structure, and for that it's just like a range minimum or like maximum queries. So like we can use sparse arrays, we can use segment trees or such, and then we can optimize this search away, and then the overall time complexity will be n squared log n.
So how many points do you get for the solution without the data structure?
You get, well, if the subtask where there is at most one tree, there's such a subtask, worth 6 points, but it can be solved separately, because on that subtask there can be a very large 2000 grid, so it can be solved separately, so basically you get 70 points.
70 points?
Yes.
And so you need the data structure and the clever stuff to get the full 100 points?
Yes.
How many kids have you seen that get the full 100 points?
Well, when I left the SC room, there were 2 Chinese kids who solved it for 100, and a few who were at this like 500 level.
Okay, well that's good, right?
Yeah.
I mean, this is what you want.
Yes.
And how many kids solved only up to n equals 3?
Lots of.
Lots of kids?
Yes.
But that's good as well, because it gives them something to be proud of, because
Yes.
we aim to not get kids have 0 points.
Yes.
So I'm going to let you go, and I'm just going to look into the camera again and say, thank you very much for being with us. Stay with us. We're going to go back to some live footage from the contest hall so you can see the stress of all the students that are still working very, very hard. And then we'll be right back with the solutions to the final task. So stay with us. Welcome back to the IOI live stream here at IOI 2023 in Szeged, Hungary. Outside it's still hot, inside it's getting warmer and warmer as well as the competition on day one comes to a close. With me is my dear friend Peter, and Peter is going to explain to us, if you feel that way, you're so smart, so maybe to you this is near trivial, but for us mere mortals, this was a very hard problem to understand.
So based on the scoreboard, I probably think that this is not the hardest problem out of the three.
Was about the third day. If we look at the closing times, basically we're saying that we leave Szeged at midnight. And the third problem, 4 o'clock, then this cannot be more than 4 hours of travel time.
Yes.
And then you have another 3 hours of travel time. The third problem, of course. So if this city closes at 5, we could still get here.
Yes.
Okay, but we have 2 big cities.
Yeah,
so we're also looking at the people going home from Budapest.
Yes. We also look at Budapest. It's the same rule applies here for any city, and our task is to maximize the cities that are reachable from either Szeged or Budapest or both. If a city is reachable from both, we count it twice.
Wow.
And this is the number we want to maximize. And the problem or the hard part comes when there is a rule that the sum of the closing times is limited. There is a limit.
So I love to paraphrase stuff.
Okay.
So if we look at the closing time as the number of hours we have police officers available to help with traffic, right? Because that's what you're doing. And starting at midnight, and the people went here and they want to go home. And the question is, to how many cities can people go home? But there's an upper limit of the total number of police hours we can assign to all the cities.
Yes, that's correct.
That's the story.
That's the story.
Okay. Now, what we've seen before is that we always start with a simple subtask.
Okay.
What's the easiest subtask we have here?
Okay, I would create a variable that's called there is the limit that the sum of closing times is at most k. So the easiest subtask, there are 2 different constructions of subtask. One of them is general, and the easier is a line, which is there are no edges.
Right.
Of this line.
It's just a line.
It's just a line between city X and Y, and or it's not necessarily, cities are not necessarily at the end, it can be in the middle.
Right, it's a tree, so it could be like this.
Yes. And the easiest subtask, we also have a limit, so we say that the distance between city X and city Y, cannot recall. It's greater than 2k.
Okay.
This limit helps us or tells us.
That tells us something about whether you can visit a city twice.
Yes.
Because if the distance is greater than 2k, well, it could still be equal to 2k. Or is it strictly greater?
It's greater?
Strictly greater than 2k. So we know that if we start here in city X, that there will be a point here.
Yes.
Where we cannot go any further, and we know that if we start at city Y, there will also be a point here where we cannot go any further, and no cities will be counted twice.
Yes, and because of this, it becomes a very easily solvable greedy problem.
Okay.
Then we just start at these 2 cities. We assign closing time 0 for both of them because
this is midnight.
And we pick the cities next to them, and we put them into like a priority queue. And we all greedily always take the one.
So we choose the next city to add. That's the cheapest when it comes to our overall number of. Right.
But,
okay, so this is the trivial task. How many kids solved this? How many kids started by? Right.
Because
police hours. So we keep thinking, okay, so are we going to have this one go farther there, have this one go farther there, have this one go farther here or have that one go farther there?
And we can do
Police hours.
which is the minimum distance. And now in a priority queue there will be the difference between the two distances from example.
Okay.
So and we do that, and if we
Police hours.
so in the priority queue we always add new
Right.
cities with the distance, and if we want to add a city a second time.
Police hours.
Yes.
Towards the end of the contest. This so far has only been a line, but I see a tree here. Give us some hints as what we should do if there's a tree.
And they cannot meet.
Okay.
Let's say. The other one that there is at least one city which is reachable from both. The first part is easy. That we can say that cities which are reachable from both can be only special places. So let's say this can be the route will be the city in the path, and it is true that coming from the middle, we can always increase this set with cities. So let's say this after this, we can count this order based on the distances.
Right.
And then we need to add. Then we can make sure. Then we can be sure that cities which are reachable from both can only be in this subtree or this subtree. Probably this subtree, but nowhere else.
Right.
And there is also one thing that in this subtree and this subtree there can only be cities which are reachable from both or none. This is a very interesting property. This is an interesting proof.
That sounds a little, that sounds like a big step you make
Yes.
there, but I know you have to get going. So
I can say a little bit more.
we can ask the viewers at home to put it in the chat if they see the property, right? I mean, that's why we have all these things here. So what we'll do is we'll end this, so you can go back to the final minutes of because I don't want to take you away from the contest. The contest is more important than the viewers at home. I'm sorry, viewers. So what we'll do is we'll end this now, and we will be right back. But first, look at the contest hall and the scoreboard and see what's happening. So thank you very much for watching.
That you want to avoid. So there's always things for these people to fix.
Hello, it is Monday night now, so it's actually yesterday from when you're viewing this. It's translation night. This is the night where all the leaders translate the task from English into their native language. With me is Brian Dean from the US. Brian, how are the translations going?
So far, they're going great because our native language is English.
So, do you not translate at all?
I don't think we'll have to translate at the moment because the host country language is quite good.
Oh, that's great. But so why are you still here then if you don't have to translate?
Well, we have to wait until the final versions of the problems are released. They're still squabbling over, minor details of the wording for some of the problems.
And they're keeping you here just to be in line with all the other countries?
Well, it's also good for camaraderie and to, participate in the fine-tuning of the problem language until everything converges.
Oh, well, that's really good. Well, thank you for coming on out of your busy schedule here. And hope all goes well with your students tomorrow.
Thank you very much.
Thank you. Thank you. So with me is Prabowo from Indonesia, the host of last year. It is the translation session tonight. Are you translating?
I am translating, yes.
And so you translate from English into what languages?
I'm translating from English to Bahasa Indonesia, yes.
And how hard is it to translate? Is it an easy job or you just put it in Google Translate?
No, it's not as easy as that. There's a lot of challenges in translating English to Indonesia. First of all, English has more vocabulary. It has more richer vocabulary, so some of the words are not really in the Indonesian language. Yeah, so that's one main concern in translating. Yeah.
So do you then explain the word or do you just make a lot more text? Because you have to stay very close to the original English, right?
Yes, there is two options. First is that we replace it with more words. The second one is we use plainly the English word, but in an italic fashion. I mean, we italicize the word. Yeah.
So you just keep the English in there and you ask students to just figure it out?
Yes, it's a case-by-case basis, yes.
Okay. Well, I know it's going to be a long night tonight, so I'll just leave you translate. Thank you very much.
Thank you.
And we'll find someone else now.
Oh, thank you.
Thank you. So with me is JP Pretty, the secretary of IOI. He's a really tall, smart man from Canada. And on this translation night that goes on until forever usually, what do you have to do here?
At this point in the evening, I'm around to address any emergencies that arise, that occasionally do arise during this night.
So, right. So the translation night takes very long, and a lot of countries are, still working on task one, and it's still early, so there's still many hours left. And the people around us, they just stick around because it's fun to be here. And sometimes we bring coffee or cookies to people. And so that's just what it's all about here. How do you like IOI so far?
I love it. I'm having a good time. I'm tired, as I always am, but it's been really nice.
Without giving away anything, have you read any of the tasks yet?
I have not had the chance to do that tonight. I made a conscious decision to not do that so that when I do read them, I can give them careful attention.
So you can't give anything away?
There's that too.
Have you heard from people? Do they like the tasks?
I've heard almost nothing.
Oh, that's good. Well, thank you very much, and we'll find another subject. So it's translation night, IOI 2023. This is day one. We are standing in the front of the room because we're not allowed to show you at this point what's on the big screen. There's all kinds of secret things on there. What you see in front of you is all the leaders that are translating. So let's just quickly walk into the room. Here on the first row, you see the HTC. Those are the smart technical people. So if we just go farther into this room, here you see the Australians hard at work translating the English into... Are you translating? You're not translating.
Problems to solutions.
So without giving anything away, because we're recording this now, without giving anything away, do you like the tasks?
Yes.
Have you been able to solve them all?
Can I answer that?
Well, if you can, don't give anything away. But are you smart? Are you smarter than a 10th grader?
That's a hard. I don't want to answer that question because the answer might be embarrassing for me.
So the poor thing. But you see, even Australia is here, and remember that we're forcing them to stay here because they have to put their translations into envelopes at the end of the evening. Let's walk a little farther along this line. Here we see Croatia. I know that Croatia doesn't translate, so Oh, but you translate. So let's ask him some questions. How are the translations going?
Difficult, really difficult.
What makes it hard to translate?
There's a lot of text.
But do you know all the words that you're translating?
Yes.
And do you have to be creative at some point, or is it just straightforward translation into Croatian?
Well, Croatians usually like inventing their own words, and some words don't have translations, so we make up some words to fill in the translations.
Okay, well, thank you. I'm just going to move on. I'll let you translate. So let's follow on here. So what do we have here? Here we have Greece translating. Is everything going fine?
Perfect. Everything is good.
Yeah. Good. So still going. Ireland is obviously not translating, I hope. No, not translating at all. Do you like the tasks?
Yeah.
So without giving anything away about the tasks, because this is still the night before, everything is still top secret. Do you think anyone can solve these tasks?
We'll find out tomorrow.
See that very political answer there? Very political answer there. I'll be quiet for a second. And that who you heard speaking was Misov. He just likes to speak when we're doing a recording here, which is fine. Here we're now standing with the Latvian table. So Northern European countries. Are you Nordic countries or not? No, not really. So tell me a little bit about translations. Which language are you translating into?
We are translating into Latvian language.
And is it hard to translate these tasks into Latvian, or is it very easy?
It's not very hard to translate, but the amount of translations that need to be done is very large, so it takes up some time.
Okay, so can't you just use Google Translate and just paste the tasks in there and go to bed?
I think it's not allowed.
But do you think it would be understandable by the students, or would it need more work from you in the end?
I think more tools like Google Translate are too simple and doesn't provide good enough translation. Probably more AI kind of tools should be used to get more better translations.
Maybe one day, maybe one day. Thank you very much. Good luck translating. So we'll just go farther back here. You see that all the countries are sorted by alphabet. So here we have Moldova. Is trying to watch the live scoreboard, but the live scoreboard has been blocked based on the DDoS attack. As you know from earlier today, the tech people had little duckies that they were using in case there was a major issue. So the tech people don't want to talk with me. But from the scientific point of view, everything going just fine, right, yourself?
Yeah, we're reasonably happy with how the contest is progressing, and by me being here, we are saying that there are no pressing issues for us to deal with at the moment.
Yeah, I find it very hilarious, because I asked in the room, I went to the scientific people and said, who wants to come explain a little bit about the scoreboard and what's happening here, and why are we not seeing anything? And nobody wanted to come, and then the big boss said, you know, I'm so relaxed, I'll just come. Tell us a little bit about what's happening behind the scenes during the contest, because you sit here for 5 hours non-stop.
Yeah, so what we are doing in the scientific committee is we are monitoring the progress of the entire contest, so making sure that the evaluation is progressing as we intended and so on. And also we are answering the questions posed by the contestants. So the contestants are allowed to ask questions to clarify the problem statements during the contest, and we are discussing these questions among ourselves and trying to answer them as fairly as possible, while not helping them actually solve the problems, just understand what the problems are.
How many, because the questions should be yes-no questions, right? How many questions are there where your answer is read the instructions again?
Most of them.
Yes, most of them are that. Are there any things where the students ask questions in the language that you don't understand?
Today I think all of the questions we received were actually in English. And most of the contestants are reasonably proficient in English, and it's a better strategy to ask them in English because you get a faster turnaround. You don't have to involve the team leaders to translate the questions and answer back and forth. But in the past, in the previous IOIs, we have successfully answered also questions posed in many national languages. This is an advantage of the ISC being quite diverse. We have people from multiple continents who speak many different languages. Actually, when we were double-checking something during the contest, because of a question one of the contestants asked, we were looking at an Arabic translation of one of the problem statements, and what do you know? The next year is in Egypt, and we have people from Egypt on our committee, so we have one of those look at the Arabic translation and confirm that everything is correct in the translation, and we have to just tell the contestant, reread the problem statement, please.
Right, because everything gets translated, and sometimes you get a question, you're like, ooh, could this be a translation issue?
Yes, precisely. That is exactly what was going on. When we get some suspicious question, we don't just say answer it based on the English version of the problem statement. What we do, one of the steps, is we double check whether this particular thing was correctly translated into the contestant's language.
Nice.
Sometimes we do speak the language, sometimes we do involve the leaders if it's necessary, but yeah, usually like check with Google Translate is good enough.
No, that helps, right? What's the earliest time you get a question usually?
Sometimes it's within the first 10 minutes, but such questions almost always get the answer. Just read the problem statement again. Because there are a few contestants always who like to pose the question as soon as they get to a sentence they don't understand. And if this is explained 2 paragraphs later or something like that, by the time we get to answering the question, the contestant already knows the answer anyway.
They've already submitted their first solution by that point. So, but are the kids allowed to ask questions all the way till the end of the contest, or only the first hour?
Yes, nowadays we allow it for the entire time. This is also one of the ways in which IOI has evolved. So back in the day when we actually had physical runners with papers, that had to find the team leader to translate the question and then bring it back to another room where the ISC could look at the paper and so on. We only allowed asking questions during the first part of the contest because of how logistically difficult this was, and also it meant that all of the team leaders had to be kept in a single place so that they could be reachable. Nowadays we have communication via mobile devices, so people can stroll anywhere they like. They just have to be reachable online.
You can use any team leader within 10 minutes.
Yeah,
right. So
exactly.
That's good. So do you personally look also at the source code that the students submit during the competition?
Sometimes we do, especially when it's so again, one of the other things that is
So you personally, because we've spoken with some of the guides when we were looking at the explanations, and one of them said he looked at all the source codes for all the low scores and the very high scores just to check what algorithm they were using. But you, as the big boss, do you check the source? Are you nosy enough to see what's happening?
I personally did check some of the source codes that were submitted, and mostly for the purpose of like double checking everything on our side is correct. So if we have a contestant like thinking that there may be some issue with the test data on this subtask because I think I should pass but I don't, what we do is we double check. We go through everything on the subtask and we take a look at what exactly is the reason why this contestant is failing. What is the test case? Is the test case really valid? Let's try inspecting it also by side. Let's try double checking whether it passes all the validations and so on. And when we are reasonably confident that the error is not on our side, then, but only on the contestant's side, only then we answer that no comments, sorry.
Right, no, but that's good, right? So it really shows, it really goes to show how much we care about the quality of this contest. Because it's only 5 hours, and if something goes wrong during the contest, there's no way to fix it in an honorable, honest way.
Yeah, and we also try to be as helpful as we can within the contest rules. So for example, one of the things that is maybe different between the IOI and some other contests is due to the technical details of how the solutions are implemented. The contestants are not supposed to print anything to the standard output because this can mess up the evaluation, and if they do, they get a message of protocol violation. And for this message we then have a prepared reply that when we quote the contest rules that, hey, this is the specific thing you are not supposed to be doing. And this is why,
right. So we don't want to leave them hanging. We don't want them, struggling about stuff that doesn't really have anything to do with the contest.
Exactly. So yeah, what we are trying to do in all of these steps is just
help them focus on actually solving the problems, the fun part of the contest, and not lose points on some technicalities.
I'm happy to hear that because I've been doing this for a long time. And I remember in the earlier days, there were contestants that submitted a solution where there was no end of line on the last line, and it was scored as incorrect.
Yeah.
And then it turns into a gamble of, come on.
Yeah, this has still been the case when I was competing at the IOI, and nowadays it's much better. With the feedback and everything, it helps eliminate these like stupid mistakes where you solve the task, but you don't get the points because of something inconsequential that you made.
No, but I mean, that's a nice thing as well, right? I mean, so the beauty of having the students get instant feedback is that they know whether they've done it. In the old days, they had to write the code, could not submit it to test it. They had to test it black box on their own side, and at the end, we would tell them a score. So you could spend an hour fixing something that does not need to be fixed. And now, but the hard thing is that your test data needs to be perfect. Right? If you give kids feedback immediately, you can't change the test data afterwards.
It needs to be good enough. I mean, no test data ever can be perfect.
No, but it needs to adhere to the specifications, I mean.
Yes, definitely.
Right, and you can't, but I mean, I know it can never be perfect, but you can't take points away from a student. You can't say, oh, I gave him 100 points, but looking at the test data, it was too weak.
Yeah, I mean, in very, very specific cases, if it's the best way, it can happen. We try to avoid it like the plague. We try our best not to get into such situations. Sometimes mistakes happen, like everybody involved in these competitions is human. We hope there will be no such mistakes today. We hope that...
We have controls and measures in place to try to avoid it, but something can always go wrong.
Nowadays the standards of developing tasks for these important competitions like the IOI certainly is, are really, really high. So we have a lot of tools that are helping us making sure everything works as expected. So the test data is prepared using not just generators, but separate validators written by other people that are going through the test data again, making sure it adheres to all of the constraints in the problem statement. We have a battery of different solutions, correct ones, incorrect ones, too slow, and so on. We are double checking whenever we change anything that everything behaves as expected. So it will never be perfect, but we are trying to get as close as possible.
But that's the goal. And I think what we've seen today and what I've heard, the contest today is run very smoothly. Everything went perfect. The only thing that has some issues is the outside scoreboard. But that's okay, because the inside stuff, everything for the kids is working fine. You could still see the scores, but the scoreboard that we were publishing, there was some denial of service stuff happening there, but that's why we separate these things.
Like the top priority is, of course, running the contest, so everything that happens here. The public scoreboard is like something secondary that is done as a courtesy. And the fun thing was that the public scoreboard actually worked as expected, but somewhere in between the public scoreboard and the you back home who are now refreshing the scoreboard and trying to see how your friends are doing, somewhere along this way there was a computer that was supposed to do the denial of service protection. And as many people started refreshing the site, something became...
That's what happened.
Yeah, something became active and cut you all off.
So basically we're too popular.
Yeah.
I think by now, and I'm just guessing, the contest will be over. I don't have a watch, I don't wear a watch.
We are probably in the first few minutes after the contest.
So the contest is over right now. We will call it a day. We'll be back during the second day of competition with more problem explanations and a couple of interviews. And I hope at home you're enjoying this. So if you enjoy it, great. Thank you very much for watching, and we'll see you on day 2.
Yeah, share the link with your friends, bring more people to refresh the scoreboard. Let's test whether we fixed it.
You're not helping. You're not helping. See you guys.
It's not my job, it's the technical guy's job. Bye-bye.
Welcome, everybody, contestants, guests, team leaders, to IOI 2023. I hope you found your hotels, your bags, your official IOI sunglasses. I look forward to seeing you all at the practice competition tomorrow. So I'm super excited for IOI this year. Some of the teams, this will be the first time we see you since COVID in person. It'll be a full IOI on site. We're going to have excellent problems. It's a wonderful city. I look forward to it.
Welcome everybody to IOI 2023 here in Szeged, Hungary. It's great to be here. I am really excited to be here, especially because tomorrow evening, Tuesday evening, we get to see the tasks for the first competition day. And the buzz and the butterflies in my stomach are really there because I love that moment of getting the tasks for the first time.
Hello IOI and welcome to Szeged. Szeged is called Sun City in Hungarian and it lived up to its name with this 39 degrees. I know that this day was tiring with all the traveling and checking in and everyone is having dinner right now, but tomorrow is the big day because we are going to have the opening ceremony for the IOI 2023, which is for a long time the first one to be held fully in person. Welcome.